day, engineer. We are the Group 7, and we will be presenting our project entitled Steel Build, Bar Weight and Cost Estimator. Our program is a Python-based tool designed to help users quickly compute the area, volume, weight per meter, and total cost of steel bars. This program supports three common bar types used in construction. There are round bars, square bars, and rectangular bars. Instead of manual computation using formulas, our program automates the process. It is useful for engineering students, site engineers, and estimators who want fast, accurate, and consistent results. I will now pass the presentation to Ms. Kabangon.
When the program starts, a header is displayed showing the program name, STEELBAR Weight and Cost Estimator. The user is given a menu with three choices. First choice is round bar, second choice is square bar, and third choice is rectangular bar. The program uses a try-except input validation. If the user enters an invalid value, it shows an error message and returns to the menu, preventing the program from crashing. Once a valid choice is selected, the program asks for specific dimensions. For round bar, diameter in millimeters and length in meters are required. For square bar, side length in millimeters and length are required. And for rectangular bar, width, height, and length are required. The program automatically converts millimeter to meters to ensure correct SI unit calculations. After that, the user is prompted to enter the price per kilogram, which is used later for cost estimation. I will now pass it to the next member to explain the calculation functions.
Each steel bar has its own function in the program. The application uses the following calculations. Area is equals to pi times r squared for the round bar. Area is equals to side times the side for the square bar. Area is equals to width times the height for the rectangular bar. The application calculates the volume by multiplying the cross-sectional area by the length. Volume is equals to area times the length. The program uses the typical steel density of 7,850 kilograms per cubic meter to get the weight. It is volume times 7,850 kilograms per cubic meter is equals the weight. Next, it divides the entire weight by the length to determine the weight per meter. Python's math library is used to perform all of those calculations automatically in the background. Next, the program computes the total cost. I will let the next member explain that part.
Now, we move on to the cost estimation part of the program. This section is simple but extremely important. First, the program calculates the total cost of the material. It does this by multiplying the total weight by the price per kilogram entered by the user. Total cost equals weight multiplied by price per kilogram. After computing the cost, the program moves on to displaying the results. Everything is shown in a clean and organized table which includes the type of bar selected, all the entered dimensions, the computed cross-sectional area, the volume, the weight per meter, the total weight, and finally, the total cost in pesos. All of these values are presented neatly using our customized print result function, which formats the output to look clear, readable, and professional. Once the results are shown, the program asks the user, "Do you want to compute again? Yes or no?" If the user types yes, the program automatically returns to the main menu. If the user enters no, the program displays a short thank you message and then closes.
To summarize, our program works because of these key features: modular function for each bar type, automatic unit conversion, built-in steel density, error handling to prevent wrong input, fast and accurate output, and cost estimation for real-world use. Application. It reduces manual errors and saves time in estimating materials. This project demonstrates how programming can solve real engineering problems and improve productivity in construction and design. Thank you for listening.